No, it's just I'm just thinking.
How was this morning meeting? Good. Anybody taking my class before? You?
Yeah.
Which class? Which class?
Application development.
Application development.
Database with things, you know.
Very nice.
Yeah.
Good. What are you doing now?
I'm just in the process of trying to graduate. Graduate in December.
Okay.
So
I see.
yeah.
I'm going to do a recording of this lecture, just in case somebody needs to review it. Okay. So make sure that you have access to the computer. So if you're a student, you have no problem. If you're not a student, do you all have access to the computer, right? Okay. And yeah, I think I was told that you will be given like a temporary account. I think we'll have to wait for 5 minutes, right? Five more minutes, just in case somebody else showing up. Assume that everybody is just kind of no background with R, is that correct? Okay, so originally I prepared like a 120 slides. And then I was told that, oh no, everybody is beginner. So then I cut it to like 80 slides. I will be happy if I can finish up to 60 slides today, okay? So that's my plan. We'll see how much we can do. If we reach the 60, then that's my expectation. If not, it's okay, it's in the slide. Okay, so basically, you will be able to follow the rest of the slides. So the beginning part will be just how to get used to this environment, and then some beginning part of fundamental programming. And after that, I think it should be not that difficult. Okay. By the way, my name is Liping Liu. I am a professor, basically teaching all hardcore stuff in data analytics and system information systems. So everybody, to graduate from here has to pass my hard courses, right? So database,
systems integration.
System integration is hard, right? Yeah. And data analytics, or advanced data analytics. Right? So those are all hard courses. And this is my 20, how long have I been here? 20 years already. So long, right? And I did not imagine that I will work for one place for more than 20 years. So originally I thought maybe 5 years, go somewhere else, and then 5 years do something else, But after you settled, it's kind of like you're settled, and then it's not that easy to move. Anyway, I love this place. I like it. So you guys have any connection with university background at all? The rest students here also.
Grad program here. Graduate school here.
Graduate school here. Okay. Yeah. So visiting professor. Professional. Okay.
Yeah, saying no Akron school history here.
Okay. So walking somewhere. Okay. What about you? No connection. Okay. No connection. How did you find our program? Okay. Yeah, I live very far from here. Typically, it's like almost like 1 hour drive. So I don't usually participate in in the podium meetings. But I really love to have more, participate more. Maybe in the future, move back to like somewhere close by. All right, I think we can get started, right? Can we? So if you go to web page and then go to ecourse.org. If you go to let me show you. Hold on. Right here. Can you see that? So if you go to ecourse.org, okay, and then just very bottom somewhere say like blogs, and the very first one say R programming workshop, and click on that. And then there are a couple of files you probably can download. So first one is just my PowerPoint presentation. That's just my guideline. So this is more like a hands-on class, hands-on tutorial. Okay. Yeah, the blog, and then look at has everybody found that? Our programming workshop, and then the bottom somewhere say download the GPT file. You can just download that file, and also there's a data file. You can just download that. It's a zip file, so there are a bunch of files we can practice today. Okay. Then I'm going to just use a PowerPoint for basic introductions, and then most of the time, as I said, we'll be doing hands-on. Okay. So let's get started. All right, let me go to PowerPoint editing. Slideshow. So that's what I said. I have like, oh, I think I have like 80 slides there, but I will be happy if I can get it to like 80 slides, 60. Okay. There are a few more slides after that. We probably do not have time to cover. All right, good afternoon, everyone. Let's just get started. And then first of all, let's just get some basic facts about R. Okay, so that's just, it's not really nothing to do with our code, with our programming. That's just let you know that you have some kind of basic knowledge about R. So R is not just programming language, but also environment is programming environment. So we'll be learning language elements and also environment. Okay, so that's my goal. And R is number one, actually, most popular one for data for statistical analysis, okay, and the visualization reporting too. So people may ask, what about Python? Python is also pretty good. Python is more like all-purpose one, all-purpose programming language. It's not really just for data analysis, okay. And then R was created by these two guys, Ross and Robert, and that's why it's named named R. And R is open source, it's free. So people asking, should I use R or use SAS? I think, there's no reason to use SAS, just use R. Okay. All right. And next, language basics. So say R is an interpretive language. So basically, what does it mean is you are not just like writing code in C# or Java. You have to you write source code and then compile it into executable. You don't have to do that. Basically, R, you write commands, and those commands will be executed on the fly. So basically, the commands will be interpreted by the R environment. Okay, and R allows it's not like, it's really high level language, but it's not that high. It's not really a fourth generation language. Fourth generation language like SQL does not allow you to have loops, if else, those kind of things. But R does allow you to have that. But R is not as low as Java or C#. Okay, so R is probably somewhere like in the middle between third and the fourth language. It does allow you to have branching and also looping. So what differentiate R from some other statistical packages is that it does allow you to write a code to automate some kind of statistical analysis. So for example, use mouse clicks, you can do something, that R can do. However, R will be a lot more powerful. So basically you can do hundreds, thousands of tests just in no time. But if you use some other statistical packages, you have to take a couple of days to do the things that R can do. Right? So that is the differentiation factor. And R allows language, R also allows packaging multiple commands into performing a task like a function. And you can also create your own functions, put into library, put into some kind of package. Okay, so that basically, if just say you have a lot of functions, you're going to reuse, you can just put it into package, and then next time you don't have to write, copy and paste the same code again. So that is a great feature. So I'm going to skip about R installation. Basically, we already have R installed in this lab. But if you want to do that, reproduce some of the stuff here we did here. So this basically is just the places you can just download and then follow the instruction. It should be very straightforward. Okay, and now let's try to get our hands on the R. Okay, so let's So I'm going to, let's see. Oh, you know what? Just let me exit this form. Okay, so if you right mouse, if you click on your Windows, okay, and then you should be able to find R in your in the list of programs here. So sometimes I just type R to search, but it may not be working. So it's have to just find it in this way. So this is R here. Okay, so the version, the current version is 4.2 something, and then you can just get the current version, I think. And last year we had a problem with this current version. We're trying to use a package called R Oracle, and that does not have support for this new version. So we have to go with older version. And then this year I found like a way to install that R Oracle package into this newer package. And I think I put that into my my blog too, just in case if you need to follow that. So let's open that. Okay, so here after you open it, it will give you some kind of like a welcome screen here. And then let's say if let me just try to make this font size bigger so that everybody can see it better. So let's change this font size to maybe like 14. Line. Okay, so now there we go. So we have that. Okay, so after you open it, and then there's another thing you probably also want to open. That is so-called script, new script editor. Just go to open a new script. So what does that do is you can just if you don't like type commands, might make a mistake, correct a mistake frequently, then you can just type your commands in here. Okay, so in fact, if you have like a long, many lines of code to write, then just probably it's better just write here instead of writing line by line here, and then you make a mistake and then go back to correct that. Okay, and also if you like just one command, just write here, and then you can just send the command to here directly. So basically, this is just like a some kind of feature similar to our studio. I don't know, sounds probably you already heard about our studio. Our studio is just a little bit. It's not a great help. It helps a little, especially for beginners to learn R. Especially give you some kind of intelligence. For example, when you type a comments, it actually give you a sense, give you like a hint, what how the comments will be completed. So as a matter of fact, I discourage my students to do that because I want them to learn instead of just using intelligence to figure out things. So it's anyway, maybe it has pros and cons, but in any case, we are not going to use our studio in this class. Now, after you open it, if you want to close it, just simply press this button, or just simply type Q and then let's see. Q. Okay, so here, if I just type Control R here, I will send this command to your R environment. And then at this point, it will ask you, do you want to save your stuff or not? So basically, if you create a new objects, new variables, data already in there. So do you want to save those stuff or not? Then you press yes, then those things will be saved. And next time when you reopen it, those data will be reloaded. Okay. So I do not have anything to save. So I just simply say no. Okay. So okay. And then let's reopen it again. Okay, it's already here. Okay, so that's how to open and close. Let me also just don't forget to open this script editor just in case when you type multiple commands. Okay. And also let's make this font size bigger so that we're not big. Okay, so let's change it to 14. So all right, so we are going to, so the first hands-on lesson we are going to do is just basically using this like your powerful calculator. So you all use calculator to punch numbers, like do calculations, right? So basically this R can help you to do that. So let's just try to do a couple of exercise here. Suppose I want to do some kind of a calculation, for example, 2.3 times 4, then you get that number, right? So you can just use this calculator, just like, like a smart calculator, okay? And let's do one more time. So suppose I want to do square root of 1 plus 2i. That's a complex number, right? Okay, so you can just type punch calculator, you do the same thing. All right, so this is this result of that. And then let's say if I need to sequence multiple commands, so very likely I want to store the result calculation result into a variable, and then I can reuse the result in some other steps. So if you do that, then you can just do something like say x equals to, for example, square root of 1 plus 2. Okay, and then after you that, the calculation is done. The calculation is finished. However, the result is just stored in X. It's not showing. So then you can just type X and then you see the result. You see that? Okay. And so there's a shortcut here. If you want to see the result and also, hold on, let me see what it is. Okay, so I was trying to get the bottom of my screen, does not see a right here. Okay, so let's just say if I want to see the result and also put data into a variable. So say if I say x equals to square root of 1 plus 2i. Okay, so in that case, you put it inside the parentheses, put everything in the parentheses, and then you will be able to see that you will be able to do both. So you will see that you get the result and also store the value into the x. So you can still have x access to x. What happened? No. Oh, hold on, x. Okay. So that is so basically you can use this the calculator. So I'm going to skip that, and now let's go back to PowerPoint, and then we'll talk about general commands, functions. Okay. Question? Yeah. That's correct. Yes, that's a very good question. So basically this type, the type you add variable x, we call object. Okay, variable is object. Object is a variable. So the variable, so in other strict type language like C, Java, C Sharp, you have to define the type first, declare the variable, and then assign value to it. But here you don't have to. It's just basically use this type is going to be determined by the value. Okay. Yeah, but what the value assigned. So if you, for example, at this point, if I change to changes say x equals to 2, 3 is greater than 2. So you know that that's just basically checking to see whether 3 is bigger than 2. That result is true, right? And then in that case, the x will be turned into 40. Okay, so that's very flexible with data type. It's not strictly typed. Okay, so now if you say, by the way, if you want to care, if you care about data types and you want to say what type of data of x is, just type class of x. Okay, so that will give you say this in this case x is logical. Okay, and then previously we had, let me just go. So by the way, if I use the arrow key up down, you will give us the previous command. You can retrieve the previous command here. Okay, so in this case, now let's type class x again. Okay, then in this case is says complex number. All right, and you can also use is complex of x to tell whether is complex or not. Or you can use is complex, or is numerical, is integer, or is character to tell whether a character is of the object is of that type. So that's just in case you care about that data types. Okay. All right, very good question. Okay, now let's get to function. Any other questions So if if I running too fast or too fast, it should slow me down. Okay. Otherwise, assuming that this basic stuff should be simple. All right. So let's talk about R commands. So R commands are mostly just functions. It's calling functions. Okay. So when you're calling the function is just like what you typically learn in the middle school. Like sine function, log function, that's function. So basically to use to call the function, of course you have to have function name, and then you also have to provide data to the function. For example, if you want to calculate sine of 1.4, right? So you have to type sine, the name of function, and then parentheses inside that provides say what is input data, right? That is so-called argument. So let's say argument is 1.4. So in our previous example, we do square root. Square root is function, right? So function, the argument was like 1 plus 2i, right? So that is called an argument. And then the object, so in general format, that you're going to have something like this, right? So y equals to fx here. So this f is the function name, and x is argument, and then the result of the function call will be stored into this variable called y, and that is called object. Okay, that will be used to store the calculation result temporarily. Okay, and then before you save your data to the hard file, this value will be just temporary inside your memory, and then if you close your computer, this y will be gone. Okay. All right, and so that is typical function call, and now we talk about that. So just you can type comments just inside the prompt. Okay, that's like a greater than sign thing, right? Type that, or you can just use up key or down arrow key to move back to previous commands or go to go through different commands. And if you can type history, it would give you all the commands you have written so far. So just in case, so after you type so many commands and get so many data, then it's a lot of comments will be disappeared from your screen. But you can type history and give your comments back. Okay. And type of comments inside script editor, and then just Control R to send the comments to the R. So that that I already showed you that. Okay, so what if you type a long comment? Let me just do that. Okay, so a lot of times you type comments and then the comments was not closed properly. So for example, if I try to type plot, okay, so I'm trying to type a plot or something. Okay, trees of course. Okay, and then I hit enter and enter. You're just you're not able to get out of it. So if that is the case, just simply type Control Z to get out of it. Okay, make sense? All right, let's come back to the PowerPoint again. We're going to use the PowerPoint as a guideline. Okay. And now let's say if you're unfamiliar with the plot with a comment. So suppose I have I want to do plot, but I forgot how to use it correctly. And you can just put a question mark and then plot. Type question mark in front of the name of function, and then to open up a page which will show you how to use it. Like that. Okay, and then you can just go to, for example, generic XY plotting, and it will tell you how to use this function. Okay, and then you can actually use there's another function called example, and that will actually give you examples of how to use the function. So example plot. Okay, so here now you see that immediately you see this plot is open, but then if I click the mouse, give us what this the command and also the result, and then click a few times, and then you'll be able to see a couple of examples in there. Okay, it's pretty cool. All right. Okay, now let's go to. Okay. And I think, okay, so let's just say we did a couple of comments here. And now let's say, how do I know that what variables I have created? And how do I, for example, change, for example, some of the things in there. And let's just say at this point I created X, Y, right? So if X, do I have Y? I don't have Y. Do I have, yeah, I have Y. I don't know where, how do I get a Y here? So let's just say we have a bunch of things, and then we look at trying to see what objects do I have, do I already created? So just simply type ls. Okay. ls. So at this point, I have x, y, tp, ey. You probably don't have those. I probably just inherited from my previous session. Okay. So let me close this plus for now. All right. So type else. And then if you want to get rid of something, you can just simply type remove. Okay. And I say remove x. And then this x will be gone. Okay. And then list again. And x is not there anymore. Got it? Okay. And let's say let's say we are say suppose you do not like, say by default I think that the number of digits is like a default number of digits, number of significant digits is 7 by default. So all the numbers represented that like that. So for example, if I do square root, let's just say y equals to 2.3 to the power of 4.5, it will give you the result which has 7 significant digits in total, right? Yeah, 7 significant digits. But if you want to change that, you want to say, I just want to say, you know, have 5 significant digits, then just say options, and then type digits equals to 5. So let's just change the number of digits. I think you need to put a double quotes around 5. Is that options? So now if you do that again, say y again, y has only like a 5 significant digits. This is a 4. This is a 5 or 4. Options digits equals to 3. Let me see. And then say y. So you have 3 digits here. Okay, so that's that basically you can use that to control how many, you know, the output significant digits you want to keep, you want to use. Okay, and let me close that. Let's go back to the PowerPoint and go to the next slides. And let's say, what if you want to, so you get a lot of result, and then the result somehow you want to save into a file, and because otherwise you know the result would be just like you skipped in front of you, right? So in that case, you can save your result into a data file by using command called sync. Okay, so first of all, let's just say sync. I want you specify sync file name. Okay, sync to say my output, right? Output dot txt, something like that. Okay. Now after that, all the result will be just automatically saved to the file. So let's just try and do a couple of things here. Let's see what x equals to, let's do, say this time I will do square root of again, square root of 1 plus 2i. Okay. And then say y equals to, let's just say we would do log of 23.5 to the power of 12. Okay, so we have 2 results already, and now let's just use, and then let's close the sync. Okay, let's just sync again. But this time we don't provide the file name, just sync. So sync and then provide for file name. That basically say all the results will be synced to the file. And now after you finish sync, after you finish the result, finish all the comments, and then you sync again. So at this point, your file will be saved. The file name is called myoutput.txt, and then you wonder where is it, right? So where is it? It's actually in your working directory. How do you know which place is your working directory? You can just type get wt, and that will show you what is your current working directory. So by default here is C drive users, username and documents. In other words, is inside your documents folder. And if you do not like this, you can change this. You can just set WD, and then inside here you type, for example, say, maybe 10 something, So I'm not going to change that because we may not have a directory called that. But I just give you the example. Say if you want to change this working directory to something else, you just set WD. Okay, so that is just so now let's say after I know that working directory, and then how do I know that files inside? Well, of course, you can just open up your Windows Explorer to look at it. You can also look at here. So for example, if you type dir parentheses, just like a DOS command, you will be able to see the files, list of files you have inside the working directory. The one I just created is called my output.txt. Do you see that? Okay, so you can just go to your Windows Explorer to find the file if you want to. So that is to do that quickly. So Windows Explorer, where is it? Here, right here. Okay, Windows Explorer, and then you find your documents. Let me open up that folder. Files is not very good. Okay, so let me get that here. So this is the Windows Explorer, and then I look at my documents, and then the file I just created should be in there. I think it's right here. This is my output.txt, and then close that, open that. What? There's no file in there. Why? Oh, I typed 2 objects, but we did not return any result. Do we? Let's do it again. Yeah, I think we just created 2 objects, but no result was returned. I believe that's the reason. So let me go back to here. Okay, let's do it again. Sync. Okay. So this file name is my output again. .txt. You can change it to any name you like. Okay. And then let's just say we have, you know what? Let's just say that now just show my contents inside the working directory. Okay, so now you're supposed to get list of files inside the working directory, right? And now you don't see it because it's already pumped into your file. Now if you sync again, okay, if you go open the file, then the file should be in there. So let's go back to Windows Explorer. And you see there's content here, 2 GB. So this is the result of the execution. See that? So just in case, if you have a lot of results, lot of outcomes, and your screen just will not, some of the outcome will be displayed from your screen, and this is a way to do that. And we'll also learn how do you find out what's your working directory, and also how to set working directory, right? So let's go back to PowerPoint. Okay, so this is the place I was telling you. Sync directory, list directory, and unsync. So this is just showing some kind of like a calculation result. Okay, so you can do any other calculations. The result will be displayed. Instead of being displayed, the result will be synced to the file. And then this get WD gives you working directory, so on and so forth. Okay, so let's move on. Let's talk about the packages, and that is actually we get into a little. So at this point, we have what we have done so far, just using R as like a calculator, right? It's not really interesting. Okay, so starting from packages, well, things will get more interesting. So what is a package? This is people wonder why R is so good. Why R is so good? It's just because R is not a low-level language like C. C is, of course, the king of all programming languages. All operating systems, all this database will actually written in C language. Okay, and that is, is probably the best, most sophisticated language. But R is not as powerful as C. Is not as powerful as C++. However, people love R. Why? Because R can be as powerful as C and C++, those languages, even though it's more like a higher level language. The reason is the package, because you can use C, C++, or Java, and pretty much any programming language to write comments, to create functions, to write a code, and to make that as extension of R. So then inside R, you call those functions that you write in C or C++, and then those functions will be executed as fast as written in C. So that's why R is so powerful. Get that? So in terms of language, it's much higher level. Higher level language is actually closer to our human language. Okay, it's not even compiled. However, it runs very fast. It's just because a lot of packages, a lot of extensions are written in C or C++. Okay, so so the package is the way to go. Then yeah, so basically, you know, if somebody using like a C or C++ written some kind of package, and then you are using R to call those functions, to call those code inside, you're using C, then you expect that that code should be very fast. Okay, and so what do you see inside the package? The package will be just inside the package. You typically just a bunch of functions or commands plus testing data. Okay. And then those packages can be installed on the fly. So basically, whenever you need it, you install it. If you don't need it, you don't need to extend. You don't need to install it. Okay. So for installation, most of the time, the packages can be installed straightforwardly. Just simply use one command. But occasionally, you may need to add something extra. For example, to install something like R Oracle, then you have to install things like Oracle instant clients. To install something like for example, to load Excel file for something, then you have to install Java code. Some packages may involve using Java machine, okay, virtual machine. So then in that case, you have to install Java. So, but besides those are very rare. But most cases, the commands actually can be installed just using one command. I'm going to show you how to do that, and then. So our packaged functions are called our commands, but executed as load. Okay, so I already talked about that. So then after you install the package, to actually use the package, then you have to load package. That is just just make that accessible to you inside your command, right? And if you don't load it, even though it's installed, then those packages may not be accessible, still may not be accessible. Okay, so basically to use a package, you need to do two commands. One, install. Second one is just load. So library or require. Okay, so let me see whether there's any more slides here. Our installation. So I'm going to just do a couple of installation here. So basically, it's a command is install package, package name inside, and then to load it and just say library package name without double quotes. So, or you can just require. There's just two commands to use it. So let's say I will use a couple of examples here. Okay, let's say do plot. Okay, plot 3D as package. And then we can do a couple of other examples. Let me open. So let me just put this away. And then let's come here. Okay. So first of all, let's say I need to install a new package called plot 3D. Okay, so install plot package, packages. Okay, and then inside there you put double quotes and then say the exact name. Exact name is plot 3D. Okay, 3D is capital. And then first time you do the installation, will ask you where do you want to install it. So basically our archive is a distributed network of databases. So basically you can pick up any location that is close to you. So at this point you can choose, for example, let me show you this. So you have a lot of distributed nodes for this archive. So let's say there's one maintained by Case. So it's inside Ohio, is Ohio one. That's pretty close to us. So let's select that one. There we go. So just a couple of comments, a couple of lines, and then sometimes the package may depend on some other packages. So you need, they will install those dependent packages too. Okay. So at this point, let's say we have package installed, and then you say the location here. Okay, this default location. And now let's say I want to load the library, just simply type library, and then say the name is plot 3D. So in this case, you just don't, you don't put double quotes around it. Okay, and the equivalent, I just say required. So that's just same thing, required plot 3D. Okay, so it's the same thing because it doesn't, so you say it does nothing. And after, so you have the package, and then just say what you want to know, something about the package, and you can use help package, and then say package equals to, and then you put the name of the package. They say plot 3D. So that's so that will open up a list, open up a package web page. So you see that the content of the page is listed here. There are a lot of comments and also there's a lot of data set in here. Okay, and you can also look at the contents inside this package by using list. Okay, and then you put like double quotes and then say package colon, and then say plot 3D. So what does this do is basically looking at the content of this package. So just get the names of those functions and also data set by just using the list. So typically, you will just do list and then nothing inside. Okay, no arguments. And then basically you will list only the object inside your own environment, your current environment. But now we are listing. What does this do is listing the environment inside this package. Make sense? Okay. So that's just doing the list. Okay. And then if you say you look at you found one function, okay, that function you really want to use, and the function is, for example, drawing like a 3D perspective. There's a PSP 3D, something like that, I believe. Perspective. Did you say that? PES perspective 3D. Okay, so just so suppose the function I want to use is perspective 3D, so just PESP and then 3D. Okay, so type of function, type of question mark and 3D, and we'll give you the web page to show you how to use the function, right? So we already talked about how to look at the function, So that basically the function that that's one of the function that will give you functionality of drawing 3D plots. Okay, and okay, you can also use example PSP 3D. So that will show you how to use examples, right? Cool. So now if you click mouse and generate a bunch of 3D diagrams. Okay, so this this is actually very useful. If you have a have a 3D and then you can just generate just generate a 3D perspective picture, and actually you can turn this around, by changing this this edge angle and horizontal angle. You can change it, turn things around. So look at a 3D picture for different perspectives. Okay. And after you have the package installed, and then if you say I don't want this package anymore, in that case, just do detach. Okay, so you do detach, and then you put a package name. Okay, so package, and then say plot 3D, something like that. Okay, and then you can also specify you want to unload load equals to true. Okay, so that was just unload the library. And then if you want to get rid of package completely, just remove packages. Just opposite to install. Remove packages, and then the name of package plot 3D. There we go. So the package is removed. Make sense? Okay. Now let's do one of the packages that we probably will need today. That is which package we need. Let's say suppose I want to do Bayesian learning. Okay, Bayesian learning. and learn something. So let's say install the package. Okay, and then this is and learn. Okay. So the second time you do that, it will not ask you for the archive. It will automatically pick up the archive you selected before. And then to load library, do that library and learn. Okay. There we go. So you have package. And then if you want to get rid of it, detach. Okay. Let's say package. And and learn. And this unload equals to true. That remove from your current environment. And then if you want to remove, and then say remove packages. Okay. And then say and learn again. Okay. All right, so that's basically handling how to install, how to remove packages. And at this, so from now on, we're assuming that we know how to do, whenever we need a new package, you know how to get it, how to load it. Oh, by the way, if like say you're trying to install a package, let me try to install a package, install the packages. Okay, then just say, I think there's one package called the Redwood data. Let me just show you the name. Yes. Okay, is this package Redwood data. What's happening to my PowerPoint? Let's go to this screen and Redwood data. Where is? Okay, so this right here. Okay, so this is Redwood data. Do you see that? Suppose you want to install that package, you will find out that it was telling you that this package cannot be installed. That data. Okay, so what did you get? Could not find the function called install. I did something wrong. So I just say I put the function name incorrect. Install packages, AGEs, okay? And then it was just trying to do it, and then after that, it will come back to say, something wrong. So this is not installed. So a version of this package for you, version of our might be available somewhere else. And so basically it's not available for you. And that's one case. Another possibility is, when the R core is upgraded, but the packages have not been upgraded, so those packages cannot be installed into newer packages, newer R. So that is another possibility. So in any of this case, this is what you can do. You can just go to, say, for example, Google. Okay, let's say you will say Google, find out, say R. Okay, and then say Redwood data. Okay, package. So you should be able to find that package right here, package Redwood data. And then after that, you will be able to see, that formerly available version can be obtained from here. Let's just click the archive, and then there we go. So we have a package called the Redwood.data. Okay, so let's click on that, download it. Okay, let's put into any place. Let's say put onto desktop or anywhere else. Okay. So this package is downloaded, and now let's see how can we install a package that I downloaded instead of from default archive. Okay, so you do some, you just use same command, install packages. Okay, and then you can type a file name, put inside double quotes, but that is going to be very it's very easy to make a mistake. So I would just open up Windows Explorer to find the file. So the Windows file.choose, and then use function. Okay, and then in this case, because we are not using repository, using the archive. Okay, so we say repos equals to null. To say I do not have repository. Okay, are you following me? And then press enter, and then we'll all automatically open up Windows Explorer, and then you find your file package that you just downloaded, and then this package will be installed in that way. Okay, so now it's done. Package is installed. Okay, so that is a trick that you have to go. Sometimes a package may not be available for your version. Then you can install it, download it into file, and then install from the file. Okay, so sometimes you may say, to install this package, you need another package. That package version, the current version, is just too new, right? It's not cannot be used for this package. So what you have to do is go to the archive, download the audio version, and then install it. Okay, that is how we do it. Okay, all right. So we have 50. How many minutes we finished? 15 slides. That's not very. Is that fast or is slow? Okay, so now let's get into package things done. Okay, so far we have covered 2 topics. The first topic is about just using R as like a calculator. Okay, and R environment, okay, getting files, saving files. The second topic is about packages. So how to get some extension to be installed into R, right? And now let's talk about programming aspect, objects. So anything you save temporary data, or you create a new code, new function, all those will be called objects. Okay, so you're going to store those into the objects, into variables. Because sometimes we call the objects, sometimes we call variables. So basically, so R allows you to store those code and data as objects. So let's just try to. We do not have time to get into functions or loops, those kind of programming aspects. So my goal is trying to get you to get you start to see how to use R for you. For example, if you want to do some kind of statistical analysis, then you should be ready to do that. But if you want to do some kind of automated things, writing R scripts or that, then you have to use how to run functions. But in general, this how to write a function. We'll just do one function, okay, at least. So let's just do. So let's say we can use objects to store data, and then we can use objects to store code. Okay, so at this point, I'm going to use my script editor. It's because we are going to have a few lines of code to write. Okay, so there's a script editor here. You see that? Okay, so we can use object. For example, say I want to say temp equals to, or temperature. Let's just say what is today's temperature. Just assume it's what, 60 something, right? 65. Okay. So that is how we use object to store data. And then if you want to use object to store functions, store code. Okay, so the function can be reused. So suppose you have many lines of code, right? And you want to reuse it a lot of times. Then you create a function. So let's say I want to create a function. So first of all, you have function name, okay, equals to function. Okay, and then inside here, you're going to provide so-called input. So what should be input to your function? Let's just say let's just do something simple. Let's just say I want to convert Fahrenheit to Celsius. Okay, so in this case, I'm going to say X is going to be representing my Fahrenheit, and then Celsius, I need to use code to write it to convert it. So I put the code inside the curly brackets, close and empty close brackets, a pair of brackets, and then you can write many lines of code. But in our case, it's actually very simple, just one line code. So how do we convert? I think you need to use whatever x minus 32, right? And then multiply by 5 divided by 9, right? So in this case, the function is pretty simple. Just simply, whatever Fahrenheit minus 32, and then you multiply by 5 and divide by 9. That should be the result for the function, right? And let's just copy these 2 lines of code. Copy the 2 lines of code, and then let's just say run it. Okay. Oh, by the way, Control R will only send one command, but will not be able to send multiple lines of code. Okay, so we have to just copy and paste here. Okay. So now let's say we have 2 objects created. And then if you list, then you will be able to see that you have temp in there. Okay, and also you have F in there, right? Okay, yeah, question. Yeah. Oh, that's. Oh, is that right? Okay, so yeah, might be trying to, yeah, if you do multiple lines, it might not be okay. So suppose you have multiple lines inside the function, try that. I don't think you can do it in general. Okay, so one comment, well, typically one comment you can send. All right, and then let's say we have function, then created an object created. Now let's just say we want to call the function. To call the function, remember not function name and also input, right? So let's just say C Celsius equals to F parentheses, and then it's provide argument. In this case, argument is the current temperature. We already have that, right? We already have temp stored in the temporary data, right? So we can just use that, provide temp, instead of just hard code data 65 into it, right? So now if you call the function, then you call the C, now the C will be the result you get. So like Celsius equals to 18.3. Make sense? So that's basically just, all the two types of objects. All right, now let's talk about 5 primitive type of data objects, and then we'll get into more complex data types. And after we finish the complex data types, and then we'll be doing some applied stuff. Yeah, let's go back to this PowerPoint. Okay. So there we go. So I already told you how to list and also to remove. For example, if you want to remove objects, just remove, right? Okay. And now let's talk about 5 primitive types of objects. So R is not strictly typed. So basically, whatever type the value you specified will be the type for the object you use. So primitive types are types that you can put in your data set. So when we do data analytics, we have to put data into data set. The data set is actually data frame, right? So those are the primitive types you can put into it. So for example, the first one is what is 23, 2.3. So that's numerical. Okay, numerical is for any numbers that have decimal places. Okay, and then Y is integer. So basically, you can have anything like -1, -2, -3, 0, 1, 2, 3. Those parts, those integer numbers. That's the countable integer numbers. That's integer. And then you have a number for true or false, true or capitalized, true or false. And you can use symbol T, capital T or capital F to abbreviate it. So those are Boolean variables. Okay, logical variables. Okay, and then you can have like a complex numbers, like 2 minus 5i, or you can have characters, like say my name. Okay, or sometimes you may have like a date. Date is just like a text, so December 21st, and then 1995, something like that. You can put that inside the text. And if your data analytics somehow you need to use data type, then you have to create them as characters first, and then you can convert it into this. Converted. So date and time are not the primitive data types. They are just like a complex types composed from something that is, for example, characters or numbers. Okay, and so I already told you actually. I told you that you can use class to check or type. Right, so for example, if you have object Y and say what type of it, just say class Y. Okay, then you will be able to tell what kind of object is it. And you can also use something, is complex, is numerical, or is integer to check a type to see whether that's true or not. Okay, so that might be useful. For example, if you need to do some kind of coding. Inside the coding, you need to decide whether that column is a numerical or is integer. Then you do work or coordinate based on the type. So in that case, you can use those functions to check say whether it's those type. And then if sometimes you may have there's, for example, something is like, for example, if you have like a 12 inside double quotes, 12 number inside double quotes, that's not number, that's text, right? So you can convert it into number by using as numeric or as integer to convert something else into something that you want. Make sense? So that is also very symmetric. So basically, you can use as complex as whatever. So that gives you a way to convert it to different types. Okay, so that's just the primitive types. Now let's work on composite types. Composite types are more interesting, and that is what essential things for analytics. So first is a vector. A vector is just like an array, one-dimensional array of multiple primitive type of data is of the same kind. So you can have vector of character values, or vector of integers, or vector of days, or vector of anything. So a vector is just like multiple values of same kind put into just like an array. Okay, and then matrix is just two-dimensional vectors. So if you have those same kind of data, but you organize them into 2 dimensions, that would be matrix. And the array is multi-dimensions. You can have like 3 dimensions, 4 dimensions. That's just you can just think of arrays like 3-dimensional, 4-dimensional matrix. Okay, so all these three types are just basically just have like a structure to hold the same kind of data multiple times. Okay, so for example, if you want to observe 10 people's weight, then you create a vector called weight, and the weight will have like 10 people's weight inside. All the data will be the same kind, right? All will be just like a numeric. Okay, or you can create another vector which is like a vector of names, 10 names, then just in that case a vector of characters. Make sense? And so in those cases we use primitive types. So what about the list? A list is kind of like a vector, but it has multiple items. However, each item can be different kinds. For example, you may have 3 items. One item is text, another item is vector, is like a numbers, or third item maybe just like something more complicated, like maybe a data set or maybe a function. Okay, so list is complex type. So list actually is an interesting object. It's basically almost all analytical results. We do data analysis and create a model, and almost all model results will be in some kind of list. Okay, so we'll use a couple of examples to demonstrate that. And then the final data type is called a data frame, and that is commonly called a data table or data set. So what is data frame? The data frame is a list, but a list of vectors of the same length. So just imagine a data table, right? It has multiple columns, right? Each column is one list item, and each column is a vector. Okay, and all vectors will be of same length. Okay, but generally a list can be a different length. And can each item can be different things. Actually, it's a mixed bag. Okay, so but a data frame is a special kind of list. Make sense? Okay.
Data frames are used. That's like the basis for like a database.
Exactly. Yeah, kind of like data table. Yeah. So it's basically just if you're familiar with any other data analytic package like a Minitab, SPSS, you open up data set, right? That data set is data frame. Okay, so that's of course is the focus of data analysis, and this is a graphical picture of things we just talked about. So a vector is just like an array of multiple pieces of data of same kind, and a matrix is a 2-dimensional vector, and an array is like a multiple dimensional matrix. Okay, and then this is a list. A list, just items can be anything. And then this is data frame. Data frame has multiple items. Also is a list, but each item is a vector. All items have same length. Okay. All right. So now let's try to do hands-on with the vectors. Okay. And a vector is actually very important subject. So I'm going to just use a few more slides on that. Okay. First, let's just say learn how to create vectors. Okay. So if you have, use say function, let's just say I already have x, y, right? I don't want to reuse something. So I have x, y. So let's just say I have v1 equals to c, okay? And then inside here, you specify specify the numbers you want. Okay, say suppose I'm gonna create a vector of numbers, say 12.3 and 21, and then 13, 45, and then you can also have missing values. Missing values use NA. Okay, and then let's put another one, 23 here, and then 12 here. Okay, and then let's say we have another NA. So let's say we have V1 created. Okay, so that's all of them are same kind of data. All of them are same kind of data, except this missing values, right? So the missing values will be assuming to be some kind of numerical values. Okay, so you can check the class of V1. So in this case, numerical, right? It tells you that it's numerical vector. Okay, and then for each vector, if you want to say, suppose I want to say how many of those. So that's length. Okay, length V1. So how many? We have 8 numbers in there. Okay, and for this vector, let's just say I want to do something else. For example, I want to sum of these numbers. Sum of these numbers. So then you would do sum of V1. But you know that the result is going to be garbage, right? Because you have nothing missing values in there, right? So it's NA, right? So let's just say I want to calculate the sum without the missing values. So in that case, you just say sum of V1, and then you specify NA dot remove equals to true. Equals to true. You can type spells, you can type completely, or just simply use T. So in general, just some kind of it's a good habit. Don't use T as object name, F as object name, because if you do that, you're going to get some kind of confused. Okay, so you may take like days and nights to figure out what's wrong with your code. Okay, so just good habit. Don't do that. So now you have final numbers, sum of the numbers, but without the missing values. And you can also do some other statistical functions. For example, you can find an average, that's a mean, right? Mean V1, and then do that again. Remove equals to true. And you can also find the variance. Okay, so the variance of V1, and then NA dot remove equals to true. Okay, and what else? You can do a lot of things. Okay, you can do quantile of V1. So, these are
a summary of everything available.
a summary, just type summary. Yeah, so you can just do summary. Summary for V1. Is that what you okay? And so very standard deviation, basically that. And the vector also has one special thing that's called a vectorized operation. So let me say we have what? We have like a V1, which is this there's a vector of numbers, right? But if you use 5 times V1, say what do you get? So you're going to apply, you're going to multiply 5 by every item inside that. You get that? Okay, so that is easy to understand, I believe. However, if I do something like this, let's just create another vector, say V2 equals just say I have two numbers out there. So one is 2, another one is 5. Okay, so this will be mind-boggling, it may not be that easy to appreciate if I just type V1 times V2. Can you guess what is the result? So now let me show you what is V1, right? V1 here is 12.6, and then there's 21. Okay, so then the result is 24.6, and then 105. Do you see what it does? It's just multiplying the two vectors, element by element, but one is longer, one is shorter, right? The shorter one will be recycled. You get that? Shorter one will be recycled. In this case, because longer one is 4 times of the shorter one, so the shorter one is recycled 4 times. Make sense? So then that's how this so-called vectorized operation. Okay, vectorized operation. So this is typically done if you're familiar with other programming language like C or C++, then you have to use loop to do it, right? But here you don't have to. It's just vectorized operation. We'll do that. Okay, and what if 1 is 8 or another vector is 3? Can you multiply them? In that case, no, you cannot, because the shorter one has to be, the longer one has to be multiple times of the shorter one for this operation to be legal. Okay. Another lot of functions actually is vectorized. For example, if I want to do, for example, do like a log of this function, log of v1. Okay, it will actually take a log on each element one by one. So this is also a vectorized operation. Okay, and for example, I can also do is NA. So check whether element is a missing value or not. So you're going to get false, true, false, 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 true, right? So basically 2 of them will be true because we have 2 missing values. You see that? Yeah. So if you want to know which ones are true, then you can use a which function. Which, okay? And then put inside, let's just do this in 2 steps. Okay, let's just say, well, first of all, I will get a t equals to is NA, and then just v1, okay? So get a t like that, right? And now let's just check, use which, and then t, and this will tell you which numbers are true. So number 5 and number 8 is true, right? Okay. So this is a vectorized operation as opposed to the other functions like a mean, sum. This basically applying one function to the entire vector as just like one unit. Okay, but then when you use a vectorized operation, you apply the function to every element. So instead we write a loop to do that. Just say, you're going to do that for every element of the vector. Okay. Now let's try to give you some other ways to create a vector that might be also interesting. So let's say v2, we already have v2. Let's just say v3, okay, equals to, you can also create like a vector of true, false, right? That's a true, false, and true. You can do that, okay? So that's v3 will be Boolean numbers, okay? And then you also create a vector of like a text. Let's say I'll create a vector of names, right? So let's say Lisa. And the vector Lisa Smith. And then let's just say John. Okay, so we have 3 names here. So that's v4 will be just like a names here. Okay. And then for numbers, we have some other ways to create vectors. One is just sequence. Okay, so for example, if I do v5 equals to 4 to 1. So that means you start from 4 and then 2 and 3 and 3 and 2 and 1. So basically you're going to create numbers in sequence. And in general, if you want to create a sequence in, you can control how, start with what and from what and to what, and then by increment by what, then use a function called a sequence. That just do v6, okay? v6, I will use sequence, okay? And I will say from, let's say I will start from 10, all right? And then say 2, let's say 2, 20, okay? 2 equals to 20. And then let's just say instead of its default increment by 1, that is what sequence will do, right? If you just do 10:20, that will just create the integer sequence. But if I just do increment something like by 0.5 or 0.1, so then I will say by equals to 0.1. So then in this case, you're going to create a lot of numbers incremented in the sequence, starting from 10 all the way to 20 and incremented by 1.1 every time. Okay, so that is also that's a lot of times useful. Okay, and then you can also use so-called repetition. So for example, if I do v7 equals to repeat, so you can repeat anything. So if, for example, if I repeat 3, and then let's say I repeat 3 10 times. Okay, so then v7 is going to be like a 10 threes. Okay, or you can repeat anything. Let's say v8 equals to repeat. Let's say I will repeat level B 5 times. Then you say V8 is like that, right? And you can also, a lot of times you use so-called random number generator to generate numbers. And in those cases, the result will be a vector too. Let's just say, suppose I want to generate V9 is, let's just use some kind of like a Poisson, right? PR, so random, R stands for random, and then POIS, the Poisson variable, Poisson distribution. Let's say I want to generate 200 of those, 200 of those numbers. And then we use Poisson distribution. Poisson basically is what is distribution to simulate, and for example, if you have a store, you want to simulate, you want to see how many on average every hour, how many customers come into your store. That could be modeled by Poisson, right? And so let's just say, assuming that on average 3 customers come to your store every 1 hour. So then in that case, the Poisson parameter was 3. Let's just say we model that. Let's say 3 as average number of customers coming per hour. So all this V9 will give you some kind of a random numbers that in every 1 hour. So what are possible number of customers come into your store? So it's just 2, 2, 1, or 0, or sometimes could be more, like 8, right? So that is also vector. So you can use random number generator to generate vectors. Okay. All right, and let's move on. Let me see whether we have a next slide, which also hands-on. So next slide. Okay, so now let's say after you have vector, how do you extract certain elements of the vector? So let's just say have V1 is just like that, right? So if I type V1 and then use a square bracket, okay, let's say 2, then what do you expect? Second item of that vector. All right, but if I do V1 and then square bracket and then put some kind of an index, let's say 2 and 4, what would that be? That would be just element 2 and 4, right? Okay, and then if you do V1 and then say square bracket, I just do the -3. Can you imagine what that be? That would be just everything except third one. Everything except the number, the third item. And then you can also have vector of that. So V1, for example, C of -1 and then -5. Okay, so that means everything in the V1 except the first one and the number 5 and the 5th one. So that is how to reference to the items inside. So if you want to change a vector, then you can use that to change it. For example, if I say V2 equals to, instead of 21, let's just say I want to change it to 25. Now, oh, sorry, V1 equals to 25. So now if you change, if you look at a V1 again, then the second item is now becomes 25. You can use that individual items to change it. Okay, so let me move on. I think we already pretty much finished the vectors, I think. Okay, vectorize, we already did that. Let me show you what I was at. Okay, so vectorize operation, I already demonstrated that to you, right? And then there's aggregate functions, we already did that. And vectors, okay, let's just try to do, okay, good. So let's just try to continue two more slides of operations using vectors, and that this time let's just do plot. Okay, let's use a vector to generate graphs. Okay, so first thing, let's say we already generated V8, which is V9, right? V9, so it's a Poisson, right? Poisson with the simulation. So let's just say this time sometimes 2, sometimes 5. Let's create a contingency table of that. Let's say how many 2s, how many 5s, how many 1s, right? So in that case, you're going to use just simply use a function called a table. So let's say T equals to a table of V9. So now you get a contingency table, a frequency table. So basically there are 6 zeros. How many? 30 ones. Okay. So So that basically just give you some kind of idea that, you know, pretty high possibility you're going to get 0, 1, 2, 3, 4, all right, 5. But then not very likely to get a 6. Okay, and so let's say suppose I have this table, and then we can just plot this table. We can just do bar chart, bar plot of t. So this is the bar plot, or you can do a pie chart, pie t, not right here, pie of t. Okay, so we do that. The graph will be replacing the new graph will replace the old one. So if you want to have multiple graphs, then you can do partition. Okay, let's say I want to create a partition with like two tables, two graphs, and we'll just say mf row equals to c. There's a vector, and then let's just say I want to do two graphs in the row. So it's just in the row, just one row and then two columns. So that will just create a new partition. So I'm going to close that one first, close this one first, okay? And then let's just say I want to create a partition first. So the partition at this point is just back blank, right? But now if you do write the comments, let's say I of t, then you're going to get one graph right here. And now if you do bar plot of t again, then you get a bar chart. Okay, so that that's just we are working on the vector. So basically, most of our analytics is doing on these vectors. So now let's do another type of chart. Let's say this time I'm going to generate random numbers using normal distributions, and then we draw histograms and a box plot and also density plot, all that. Okay, let's just do a few more plots here. So first, I'm going to get rid of that, and then let's say I will generate V10 equals to, I use normal distribution R normal, R norm, okay? And let's say generate how many? I will say I want to generate 200 numbers. And then we use normal distributions. You have to say, the bell, right? The bell has to have a center and also standard deviation, right? So you specify that. Let's just say I want to do mean equals to 10, okay? And the standard deviation equals to 2, okay? Standard deviation equals to 2. So then you can type V2, V10, then you get a vector of those simulated numbers, right? So that's just a random numbers. So basically, you're assuming that you're getting randomly picking numbers from that kind of a normal distribution. You will probably get an 8.31, 13 point something, 10 point something, so on and so forth, right? So let's say, suppose I have this kind of number, and let's just try to show the distribution. What does distribution look like? Okay, so you can use histogram. Okay, histogram of V10. Okay, and by default will be just showing the count. So you're going to get like a number of counts, So basically, what is this? This is from 6 to 7. How many numbers in here? About 10, less than 10, right? From 7 to 8, you get that. And if you want to use that, if you do not want to use count, instead using frequency, then you just type say histogram V10, and then say frequency equals to false. Okay. So then you'll get those the frequency here as like probabilities here. You see that? Okay. And let's say if you want to do you can also do bar plots, right? Box plot. Box plot of V10. So that is a different way to show the distribution. So there's the mean, and then standard deviation, one standard deviation, two standard. That's just one standard deviation, like that. Okay. And now let's say if I'm going to use the histogram, and the histogram does not look pretty smooth. It's not very smooth, right? And there's one way you can make it smooth by just changing this so-called, breaking points. By default, it's like 1 point, from 6 to 7, 7 to 8, just like 1 as a unit. But you can also change it to something else to make it smooth. But there's another way to do it. You can just create some kind of like a density function from this frequency. So you can say D equals to, for example, density of V10. And then let's plot D. Plot D. So now you get some kind of very smooth picture of that distribution. You get that? Okay. And we can also do, say, originally we said this normal distribution was generated from this 200 numbers generated from this theoretical distribution, right? Mean 10 and standard deviation 2. So let's just say, let's try to draw this theoretical distribution, say how the theoretical distribution look like. Okay, so we can just do another plot, or we can even better just say we have the density function here, right? Starting almost from like what is this, 4, maybe even 0 here, and 2. So I'm going to do from 0 to 20, okay? And then I'm going to plot sort of like a sequence of points. Okay, let's just say points equals to sequence. Okay, so start from 0 and to 20, and then by, let's just say this time I'm going to buy 0.05. So it's going to just create a very tiny, sequence of points. Okay, and then let's say if you already have a plot, you can use points or lines to add new things to the existing plots. So we already have this plot here, right? So I'm going to use lines here, lines, okay, and then start, x to draw the lines. I need to specify a list of the points, right? So x points, x coordinates will be points, be these points here. Let me show you this point here. This point actually is quite a, so starting from 0 all the way like, 0.05, 0.1, like that. So a sequence of points, right? And then I'm going to use that sequence of points to use this normal distribution to calculate what it should be y, and then we add the lines, add all the small tiny lines to this graph. Okay, so I'm going to say lines here. And then say points, this x-axis, and the y-axis will be just those normal distribution. So I'm going to use d norm. D means distribution, d norm, okay? And then for the variable x is going to be points. And then we'll specify that, this mean is 10, still 10, and the standard deviation is 2. So that's 2 here, okay? So that's the point of that's the list of like what so x points and y points. So basically you get a list of x points and a list of y points. So y points in this case is calculated using this distribution, this normal distribution. Okay, and we can also set different color. Let's say color equals to. So I already have black, right? So I'm going to use red color. Okay. And then we can also change the line type. Line type instead of a solid, let's just say I want to do dashed. Okay. What else we could change? Okay, so suppose that's it. I'm going to just change the color and change the line type. And then these lines will be used to add new graph to existing plots. Okay. So let's run it. Now you see that this dashed lines. Line type 1 is solid, and the one type 2 is like just like somewhere between dashed and the solid, so like a little bit longer, intermediate long. And then the line 3 is dashed lines. So now you see that based on the sample data, I draw I get those kind of distribution. This like this black lines. And then this red lines just show that theoretically the distribution should look like that. This is pretty close, right? So that's how this this graph can be put into. And if you want to, let's say I want to put some kind of legend here. Okay, so let's just say I want to put something. This black lines is showing that is empirical is random samples, and then this red line showing that was for theoretical. So we can just also add some other things like legends, and then you can also add a text by using element text, the functions to that. So let's just use legends here. Legend. Okay. Legend. Okay. So the first you specify where do you want to put a legend. Let's say I want to put a top left. How is that? Right? Top left, or you can top right. Okay. So top left. Okay, that's the location. And you can also specify x coordinates, y coordinates precisely. Where do you want to put legends? Okay. And then you can specify, say, I want to show 2 legends, and then, say legend. Okay. Legend equals 2, and the C. And the first legend is going to be like a theoretical. Okay. And the second one, let's just say for words like empirical. 2 legends. Okay. So that specifies the legend, the actual text. And now let's say I want to also specify them in different colors. So color equals 2, C. And for theoretical ones, I said what I already put in red, right? So this is red colors for theoretical ones. I'll say red. And then for other one was black. So empirical one was black. Okay. And then so legend, and then if they will be showing different colors, and then we can also specify the type of the lines. So line type. Let's say for empirical ones was 1, and then for theoretical one was 3, right? So which is 3 and a comma 1. Does it make sense, everyone? So the legend at this point I specify the location, and I specify that it's going to have 2 legends, 2 words describing the legends. Okay, and then they will be showing different colors in those lines. Okay, and now those legends will be used to add things to the existing plot too. So enter, and now you see that they should have a legend here, right? Make sense? Yeah. So I think we need to move on. Let me go to PowerPoint again. Okay, so we did that, and we did that, right? Density or that. Hands-on practice and vectors. This one, what does this do? So this just also, you can use our existing plot, and you can also add points, add lines, add legends, add text. So anything you want to add. So if you already have existing plot, okay? Oh, this, what about X lab, Y lab? This just basically tell you, what is the label for X-axis, what is label for Y-axis, and also main is just say what is the main title for the graph, okay? And just add extra options. I'm going to skip those. And then these 2 slides I'm going to skip. Oh, these 2 slides I'm going to skip. So let's see. First one, when you create vectors and you have vector of text, but those texts are typically some kind of like a categorical variables, right? And so you want to change, if you want to change it, character values into categorical. For example, you have a list of some kind of economic status, poor, good, something like that, right? So those you put inside data as like a text, but you have to convert them into like a categorical variables. There are 2 kinds of categorical variables. One is nominal. So basically, it's just a label for some kind of a value, but that label does not have any meaning. So those are nominal ones. So for example, you have diabetes, have two types of diabetes, or some kind of gender, male or female, those will be categorical, right? So you can use those here. You can use nominal variables for those. So to create those, you just simply use something called a S factor of factor, and then inside that you have, for example, you have vector of these characters, and then you say diabetes equals the S factor or factor of that. So that will automatically convert that vector, text vector, into nominal variable or categorical variable. Okay, but the second type of nominal variable is we call ordinal variable, which is basically just those, it's nominal, it's also just symbol for some kind of value, but the values have order. For example, if you're trying to say somebody's like performance, the performance could be poor, could be good, could be exceptional, right? So in this case, those labels just poor, exceptional, good, maybe just like a label, but they have order, right? Good is better than poor, and exceptional is better than good. So if that's the case, you use factor or as factor, but you add one more option, say ordered equals to true. So make that values ordered. So that would create an ordinal variables. Okay, so I'm going to move on. Now the second type, matrix. I'm trying to watch my time. So we started from 2 o'clock, and now it's almost like one. We finished 1.5 now, right? So 1 hour time. Do you guys need a break or not? Yes or no? No. Okay, so if no, then we'll just continue.
I had a question.
Yeah.
I thought it was from 2 to 5,
2 to 5.
the workshop.
2 to 5. 2 to 5 is 3 hours, right? So it's
You're saying we have till 4?
no 4 to 5 o'clock. So basically is now is 3:30, right? Is it correct? So we already finished 1/2 time, right? Is it correct? Yeah. So we have approximately 1.5 hour left. So how many slides have gone through? 30 already? That's good. So that means we can finish up to 60 slides. That's my
I
expectation.
actually have to.
You have ready?
Sign out here.
Huh?
I actually have to, do you want me to sign out here?
Yeah, there's nothing to say about.
Okay.
Yeah, you can do anything. Okay. All right, and then let's continue. If you guys need a break, or take 10 minutes break, otherwise we can just continue. Okay. All right, so matrix is something I will not emphasize too much, because we have more important things to cover. So for matrix, you basically you create the same kind of data, but then you order them in some kind of like a two-dimensional, right? So to create a matrix, you use a matrix function. Let's just create couple of matrix here, okay? So let's just say M1 equals 2. So you do matrix, and then inside that object content of data, you can use a vector to specify that. So let's say I have a bunch of some kind of data like a 1.2 and 3.2, and then 1.4. Let's do one more. Okay, let's say 2.5. Okay, so in this case we have 4 numbers, right? 4 numbers. And then to specify matrix, you have to specify. Now you need to specify how this 4 matrix, 4 items will be laid out. So by default, you just specify. I say I want to specify the number of rows. How many rows do we want? So if I want to just say I want to do just a 1 row, okay. So in that case, it's just a 1 row matrix. It's just like a vector. However, if you change it to 2, okay, so you're going to create like a 2 by 2 matrix, right? Okay, so if you have 2 by 2 matrix, then by default, you will then the values will be filled out. Let me show you the fill out in vertical way. So in other words, the first number will be 1.2, and then the next number in the same column will be 2.1 to 3.2. Let's just type M1 again. Is it that? So by default, it will be filled by column by column. So all the numbers will fill the first column first, and then the remaining column will fill the second column and the third column. So if you want to change that behavior, you can just do say by row equals to 2. So that means you change it by default to row number to rows. So then you mute. So now you say that matrix will be filled every row, first row and then second row. Okay, so that's how you create that matrix. Let's create a second matrix. M2 equals 2. This time I just create a matrix, or it's just few numbers. Let's just say I want to create numbers 10 and 20. Okay, 2 numbers. And then this time I will say I will create a number with two rows. Okay, so that would be just 2 rows, just 1 column, right? So in that case, it does not matter which way you fill the numbers. So the M2 will be just 10, 20 next to each other, right? So So when you get into the matrix, and then you can do matrix multiplications. There are a lot of operations and functions applying to that. But one function you probably would be interested is, you learn the matrix, calculate matrix multiplication in college, I believe, or maybe in high school, right? So if you want to do matrix multiplication, suppose I want to multiply M1 to M2, the matrix multiplication that you learn in college, then in that case, you're going to make sure that the number of, so this first one is 2 by 2, second one is 2 by 1, right? So so you have to make sure that the first one, the number of columns equals to number of rows in the second matrix. Make sense? Okay, so number of columns in the first matrix must be equal to number of rows in the second matrix. Otherwise, they cannot be multiplied. And then to do the auction multiplication, you are going to use this percentage sign and then star and then percentage sign and then M2. So regular multiplication will do something different. I'm going to show you that. So in this case, is what you learn in the college multiplication. But if you just simply do M1 multiplied by M2, you know what's going to happen? Element-wise multiplication. That's correct. So that just comes just more M1 multiplied by M2. So M2 is actually a column. So if you have let me change that a little bit. So suppose I have to do M1 and multiply by C of M2. I'll convert that into like a vector. Okay, so that would be changing to element-wise multiplication column by column. So I will use that second vector, what is that, M2, that's a 10, 20, multiplied by the first column of the matrix and second column of the matrix, element by element. Okay, so that is a difference between these two different multiplications. And then you also, you'll be interested, say, if you have a matrix, you want to do like a inverse. Suppose I want to do solving linear equations, something like that, right? So in that case, you do solve and then M1. So that will find the inverse of the first matrix, right? And then if you want to solve the equation, for example, linear equation, just say the linear equation is what? Is 1.2x plus 3.2y equals to 10, and then 1.4x plus 2.5y equals to 20. If you want to solve that equation, then you're going to use that multiplied by the right-hand side equation. And then you can also do transpose. Okay, so let's say M1. Okay, transpose, you say that it's just switch rows into columns, columns to rows, right? That is matrix related thing. And then related to matrix, there are two functions that might be interesting, might be useful. Let me show you these two functions. Okay, so one is so-called, let's see, this one. Okay, apply. So when you apply and then apply a function, apply a function, for example, f, okay, to m in some kind of margins. Okay, so there's a margin. If you apply each function to a row, then you say margin equals to 1. If you apply a function to a column, then the margin equals to 2. Let's just try to do two examples here. Okay, so let's just say for this M1, I already have M1 here, right? Suppose I want to find the sum of these two numbers, each column, or find the sum of each row. So I will use apply, and then M1, okay, and then margin is capital margin equals to 1. So for example, for each row, right? So the row margin is 1, and then I want to do sum, right? So then you get like two numbers, one for each row, sum of each row. And let's just say this time I want to do multiplication of each column. I want to do multiplication on each of values of each column. So then I will apply, and then M1 again, and then this time margin equals to 2. And then let's say do products multiplications. Okay. Make sense? Okay. So I'm going to skip that. So to move on to the next item called the list. Okay. So this is a matrix. List is a mixed bag. Okay. So basically, let's just learn. So to create the list, use a list function. that's pretty easy to remember, right? So vector is just using C, matrix using matrix, right? List using list, and data frame is using data frame. So basically those, it's pretty easy, but you just need to understand what kind of structure is each type is, right? So list is mixed bag, can be created. So let me just create a couple of lists here. Okay, so let's say create a list L equals to, use list function, and then you can specify element name. So suppose the first one is equals to C1, 5, and 9. It's a vector. And then the second one is, let's just say I want to say something is like another list, okay? And list has two things inside, 1 and 3. And then third one equals to just simple number. So now you have a list, you can type L, then you get a list, and then the list items, first, second, third, okay? So each item is different. So first one is a vector, second one is a list, third one is just single number, right? Okay, so the first thing you want to for a list, the first thing you want to know, how am I going to get access to each item? To get access to each item, you need to use double square bracket, or use like a $sign. Let's use double square bracket first. Okay, let's L double square bracket. You can double square bracket, for example, 1. So that will give you the first item. So that's different from matrix and from vector. For vector, just use single brackets, right? And for matrix, also single brackets, but for list, use double brackets to get the individual items. So you can also use name instead of double square brackets. So for example, say second. So the second is a list, right? Okay, and then you can also use name instead of inside the double square brackets. You can just use $sign instead. So let's say second. So that would be the same thing. Use L and then $sign. Then after that you have a name. But in that case, don't put name inside double quotes. Okay. And then the third approach is just use a get. So for example, you can say get third double quotes and then from L. So that is a number 3 approach. So for the list, you have 3 different ways to access individual items. But don't use single bracket. So for example, if you use L and 1, you know what's going to happen? It's not individual item. What does that do in that case is actually creating a sub list with only one item, first item. So you create a sub list with just one item. Okay, but it's not the first item. Make sense? Okay, so now let's move on. And then say for list, there are 2 functions is very important. One is called the map function. Let me show you the slide first. Okay, so there's a map function, there's a reduce function. So this probably most 2 important functions apply to list. So what does a map do? Map is just applying a function to each item in the list. Okay, and reduce is applying the function to a list successively. So what does that do? You say, for example, you use a reduce, and then the reduce use a function applied to the list. It will use the function applying to the first 2 items, get a result, and use that result as intermediate result to be used applied to that with third element, applying the function. So applying the function to that result and the third element, and then you get a new result. And then the new result will be combined with number 4 items, and then apply to the function. So you can just apply that function successively like that. Okay, so let's just do a couple examples with that. Okay, so let's say we have a list L. Okay, so let's say I want to find out. Let's apply some kind of functions to that list. Okay, let's just say, suppose I want to say map. Okay, map, and so I'm going to apply map to the function called class, and then a map to the L. Okay, so what does that do is basically you're going to say for each item of L, I want to check what is data type. what is data type? So the first one is numeric is a vector. The second one is list. Third one is that, right? And you can also use, say, for example, map. Okay, and then let's see, length function to L. So object length is not mistyped. LENGTH. Okay. So you get the length for each item. Okay. Or let's do one more time. Let's say map. So this time, let's just say if I do something like is NA function to L. So you will apply into list to the list item is NA to list to every item to say to check to see whether any item has missing values or not. Okay. Now let's try to do reduce. Okay. Let's say suppose question. Yeah.
Checking items.
Wait, inside the list. Yeah. So basically, is NA is a vectorized operation. It's going to do that. Yeah. The question. Now let's say if I let's just say if I want to do something like a 2.3 to the power of 4.5 and to the power of 6.1, something like that, right? So suppose I want to do that calculation. So what I can do is, let's just say I want to create L1, okay, equals to list, and then 2.3, and then 4.5, okay, and then 6.1. Okay, so I have a list of 3 items, and then let's say I want to use reduce. So what are you when you do reduce, and then say reduce, okay, and then you specify which function which operation you want to do. I want to do this exponent, okay, and then I want to apply that to L1, okay. So this will do this all the numbers successively. So you're going to do this 2 to the 3 to the power of 4.5 first, and that result will be applied, and then you use this exponent, just step by step. So you're going to get a huge number here. So this number is just too big to be represented here. Okay. All right. So what else? List already done here. I think we are ready to go to the data frame. Okay, yeah, data frame. So data frame is a list of vectors of same length. Remember that, right? So it looks like a matrix, but it's not a matrix. Remember, matrix, all data must be same kind. Okay, but a data frame, each column can have different types. Each column is a vector, but they can have different types. Okay, so let's learn how to create vectors. So first thing I want to do is I just collected data. I have not entered into any files yet, and then I just want to enter it here. So if you like to work with some kind of a statistic package like a Minitab or a Jump, you can just do something similar here. So first of all, let's just say I want to create something like say P1, okay, patients, okay, patient 1 equals to data frame. Okay, suppose the this data have two columns. The first one is age, okay, and then you specify the age is as numeric, and then parentheses. And the second one is just say diabetes type, and let's say type is equal to, let's just say as character. Okay. Or you can just simply say equals to numeric without the s, that's fine too. So, and now let's say I have just created empty data set, and now let's say I want to create open up some kind of graphical user interface so that I can enter data into that. Okay, so you do that P1 equals to edit of P1. Okay, so now you open that data, just like a graphical user interface for data table. So let's just enter some numbers here. Let's say this is maybe 53, and the type is 1 here, and then let's say 45, and type is 2 here, and then let's just do one more here. Let's say 25, type is 1 here, something like that. And after you finish this, then just close it, and then your P1 is there. So this is data frame you just created. So if you like to work with this kind of environment to create data set, then this is the way to go. But that's probably doable if you have very small data set, right? But if you have larger data set, you probably want to enter into data file and then import it into here. So I'm going to tell you how to do that. Okay. So the second approach, you can just use the vectors to make up data frame. Let's just say create 2 vectors. Say age equals 2. Let's say I want to have 40, 55, 53, and then 45, 26, and 78. Let's do one more here. Let's say 12 here. Okay. And now let's say type is equal to, and then let's say type C. Okay. So in this case, I'm just use 1, 2 instead of using double quotes around it. 1, 2, 2, 1. So how many? So they have to be same length, right? 1, 2, 3, 4, 5, and then 1, 2, 3, 4. I think I have one more here, right? Okay. So now they have same length. If they're not the same length, of course, they cannot be in the data frame. Okay. All right. So now let's say I want to create a P2 equals to data frame, and then I'm going to use age and type 2 columns to make data frame. Okay. And then P2, you see that you have the vector created, the data frame created. So this is possible also pretty much for small data set, you can do that. Okay, instead of using graphical user interface to input data, you can just type those vectors and create data frame like that. Okay, and there are some other ways to create data vectors. And also we're going to just follow the slide here instead of jumping around. Oh, hold on, close. Total of times. Okay, so we are in data frame, right? So let's just go to current slides. So data frame here, this is the first approach, second approach. Okay, so a package comes with data frames too. So we will look at some data frame inside the package. And then, okay, so then we do hands-on exercise. So the package, so a lot of times the package will come with the testing data set. For example, at this point, if you type search, you will find out which package do you have, okay? Do you have any, yeah, those are the package in my case. But by default, if you do not install any package, you should have this package called the base package. You see that? Everybody should have base package. Inside the base package, there are 2 data sets. One is called trees. If you type data trees, so that will load that data. Okay, so now if you type trees, then you have just 3 columns, right? It's pretty simple data set. 3 columns: course, height, and volume. And then there's another one called iris. Iris is let's see what is it's some kind of flowers, I think, right? So have sample width, sample length, petal length, petal width, and also species of the flower. Okay, so let's say those are the sample data we have. Now, sometimes you may have load a large data set. For example, if you have data file which has like millions of rows, then this data set, if you just try to open it, it's going to be too large. So in that case, you want to see partial data. So you can just use head function. Okay, so head and then say iris. So suppose this data set, the data frame, and then you can specify that I want to specify only like six rows. Okay, so then you will only be able to see just 6 rows instead of loading everything. That basically you will not be able to see the entire thing. And this is the one function is useful for you to see the data set. And then the second function that you probably want to know is you want to use structure of data set. So let's say iris. So that will give you list of columns and also some data inside, and also type of data inside. So for example, species in this case is like is what is a factor, is like a nominal variable, and with 3 levels, right? And then those are the sample data, possible data in there. So this is a function that is useful. And then you can also use names or column names of IRS. That will give you a list of variables inside the data set. Okay, or column names, CO name, column names, same thing. So give you, what are the variables in there. And then if you want to say the total number of rows, total number of columns, use n col. Okay, and then n row. So that gives you total number of rows, total number of columns. So those functions are useful. And what else? And if you want to say, I want to say the data, whether how those things are related to each other. So you can use first of all, let's say you do summary. Okay, summary of each column. So IRIS. So in that case, for quantitative data, numeric data, it will give you different quantile. But then if you have like a species, which is a factor, like a categorical data, it will give you like a number of counts. Okay, so that gives the other one will be just a pairs. That basically just show the relationship between each pair of things, pairs of IRIS. So now you get some kind of a graph showing that how these things are related, how different variables inside this data set are related, every pair. Okay, so those are useful functions to explore your data set. Okay, there are some other things, some other advanced functions to do that, but those are the basic ones. Okay. All right, and I think let me see. That is hands-on portion. Let me see whether the next one is hands-on. Next one is okay. Next one is actually how to say the elements in the data set. Okay, let's just say let's do trees. Trees are smaller. Okay, trees. Okay, so if you want to get like this, for example, this particular item, this particular data, which is in row 4 and first column, then just simply use trees, just like a matrix, right? Row 4 and the first column. Use square bracket, so that will give you just particular number. Okay, and if you have multiple columns, column index in here or there, then basically get not just one piece of data, but also multiple. So how do you get multiple? How to get each column here? Remember this list, right? So we can get this list, this vectors, each column in 3 different ways. So first we can do, for example, trees. Okay, use double square bracket and then say 1. So that will give you the first column as a vector. Okay, or you can use names, trees, square bracket. Let's just say double square bracket girls. So that will give you the same thing. Or you can use, excuse me, you can use a $sign, trees and $sign and girls. So in this case, you don't put the name of variable inside double quotes, so you could get the same thing, right? So you have all 3 different ways to. Oh, you have one more way actually. You can just do trees. Okay, so use square bracket, but this time we use comma. So what does it do is the comma, so basically specify which row and which column, right? But I do not specify the column instead. I do not specify the rows, but I specify the column. So suppose I want to do the first column, okay, then you can also get the same thing. So how many ways you can say? So you can actually 3 different ways. Double quotes or using this single quote, but it's just using, using like a matrix format. And then you can use this so-called $sign to get the variables. And this is similar to this double quotes, double square bracket. Sorry, double square bracket. All right, and then this is how we get individual columns. How do we get the rows? How do we get the rows? So get the rows, you can also specify the row number, right? So for example, I want to get the first row, but no specific column. So I will leave the column empty, but just rows, okay? And you can do that with multiple rows. So for example, I have to column row 1 and row 5, like that. And then no specifics for columns. So column index is empty. So then you get that 2 rows. Okay. And what if you want to do some kind of a selection, selecting cases? So let's look at the trees again. So suppose I want to find out all the rows that have height bigger than 80. Height bigger than 80. So in that case, you can just do trees, okay? And then a single square bracket, and then single column here, and then you have a row index and a column index here, right? But in the place of a row index, you can specify how the rows should be selected. So you can say trees height is bigger than or equal to 80. 80. Okay, so you select only those cases that corresponding height is bigger than equal to 30 or 80. Or let's just say this time I want to do something else. I want to select row 2, row 4, row 6, something like that. So in that case, I will just use row number divided by 2, take the remainder, and then the remainder equal to 0, then I will take it. If the remainder is not 0, I will skip it. Does it make sense? Because I want to take row 2, row 4, row 6, right? Like that. So in that case, I will do trees and then use a single square bracket. And then inside you have a single column separate both row index and the column index. For the row index place, I will just do say n colon n row of trees. Okay. You know what I mean, right? So basically, by creating a vector, and the vector starting from 1, and then all the way to the last row number of the trees. Okay, and then I will use that divided by 2, and then the remainder equals to 0. If remainder equal to 0, okay, then that will basically I will get in the only even numbers only. Does that make sense, everyone? So I will use 1 divided by 2, remainder is not 0, so that first row will be skipped, okay? And then I will use 2 divided by 2, then the remainder is 0, then 2 will be kept, because, because this condition, the remainder is 0, okay? So that will allow you to just select, hold on, did I do something wrong? Rows, trees, color sign. Did I miss something? Trees, rows, 2 equal signs should be right. Oh, sorry, that's right. Should be divided by 2, yeah. See that? So divided by 2, and then, if you, yeah, so you because we'll talk about divided by 2. So now we take a row 2, row 6, like that, okay? So, okay, and for data analytics, sometimes you want to say, I want to pick up certain portion of data for analysis and then remaining portion for validation, right? So then in that case, I'm going to select the rows. So we can use a function called sample to do that. Let's just do the sample here. Let's say rows equals to, I'm going to use a sample, okay? So I'm going to sample from n, I'm going to sample from 1 all the way to n row of trees. Okay, sample all the number 1, 2, 3, all the way to the last number, and then I will specify the size. Let's say size. I want to take 80% for 80% for training. Okay, so let's say I want to do 0.8 times of n row of trees. Okay. So that basically say I want to take 80% of cases to be selected, and then when you do sample, you have to specify after you take one number, do you put a number back or not? So if you say replace, you take another option called replace. If you replace equals to true, that means you put a number back. So that means that number can be resampled. retaken. And that is probably not working for us, right? Because we really want all the numbers, all the cases to be selected are unique cases. So I do not want to read to say after I take a second row, I do not want to put a second row back to be redrawn for future cases. So I will do replace equals the false. Okay, so now we have list of rows. If you select rows here, so this will tell you that those are the rows will be selected, cases selected for you training. And now we can just say, let's say train equals to trees, square bracket, and then just say rows, okay? And then no column specification. So in the place of a column index, there's nothing there. So now you have a training data set, which is those cases. And now let's say test equals to trees, and then this time I'm going to do negative rows, right? Rows, yeah, negative rows. So that means everything but those numbers, everything but the one I selected. Okay, so those will be the cases that you use for validation, for testing. Make sense? All right. We have 1 hour. I think we should be able to finish 60 slides. Okay, let's see whether we can conclude this part. Windows Shift here. Okay, let's run in the slideshow again from the current slide. So we told you how to how to get columns, get a vector. Each column is a vector. How to get vectors, okay, and how to access each individual items, okay, using just a matrix notation. Is not a matrix. Oh, by the way, to access columns, there's a shortcut. If you say at this point, if you type girls, it will tell you the object is not exist, right? But if you do trees, say square bracket and the girls, that will give you the column. Okay, that will give you the column that corresponding to girls, or you can use trees, $, girls, right? You can get the same thing. However, there's a one shortcut. Sometimes you may use it, but if you have large data set, you probably just you don't want to overuse it. So that's attach. So if I attach, say trees, attach trees. So then by doing that, I will make those columns as your objects to be accessible directly without using trees in front of it. So for example, after I do that, and if I type girls, now this is a vector. If I type volume, that would be a vector. If I type height, okay, that'll be also a vector. Got it? And then if so what does this do is basically make those columns inside the data frame as objects for you to use, directly use. Okay, so without reference to the data set. So after that, for example, if you do calculations, for example, sum of volume, okay, so you can just use it directly. Okay. If you do not, if you don't like it and you want to get rid of that, then you do details. So details trees. So now after that, if you do volume again, should not accessible to you anymore. It's not object anymore. Got it? All right. So I think we are pretty much there. So I think just do a couple of applications. And data frame, to extract the rows, we already did that. To extract the rundown rows for testing, for training, we already did that. Oh, okay. Let's just talk about data import. Okay. So R allows you to import data from pretty much any other data sources. So people talk about using Alteryx, there's different technology to get data, but really in R everything is in there. So you can get data from Oracle database, from some existing statistical package like Sept, from Excel, from web page, from XML. So basically, that you can think of. Okay, it's pretty much everything is in there. So let's just start with something basic. Suppose I want to extract data from what? From like a text file. So I'm going to show you at this point. Okay, let's say you already downloaded data set, right? Download the data set from eCourse. Have you? So let's say in my case, if I open that, I'll show you the data set of data in there. So it's right here. So we have one, this is CSV file. So those basically like XML file, right? So you can save things in the XML. So let me show you what data structure look like, okay? So first of all, this is actually a simple one, like survey.txt file. And if you have a data set organized in like a tab, in the tab limited file, so I have a bunch of columns and row numbers and also column names for that. So let's say I want to extract that into, import that into import that text file into our R. Okay, so what I will do is I'm going to drag that into say downloads. Okay, drag that into downloads, and now let's go back to the R to import it. Yeah. So let's just say let's say my data equals to, let's say read dot table. Okay, and then you specify the file name, but I don't want type of file name. You can use file choose always. Okay, file choose. Okay, and then inside for this function, there are two important options you probably need. One is header. Do you want to have the header? Do you have the header or not? Yes. The first one was header, so header is equal to true. And then the second thing is if you have like a characters, like a names or that, do you want to keep those as fact? Do you want to automatically convert them as a factor or not? So by default, this will automatically convert text into factors, but I can override that function, override that feature by using say called strings as factors equals to false. So by doing that, those text values will not be automatically converted into factors. Make sense? Okay. So open, and you just look at. I think I downloaded. I put into downloads, right? In the survey, right there. So now if you look at my data, okay. So at this point, I have those text values, adult, young, all that. They are just characters. They are not factors. Okay, because I choose this as is equal to false. Okay. Now this is the first type of data, and it's common type of data. The second common type of data is like CSV file. So let's just say I want to have some kind of like a claims data. Okay, so it's Excel file. Okay, so you can actually look at. Let me just instead of using that to say that I'm going to just drag this out first. Okay, drag this out to downloads. And then go to downloads, and then let's open it using Notepad. So open with. I have a code here. Open. Do you have like a middle somewhere? Where? Let's say edit with Notepad. Do you have Notepad ++? Yeah. Open with middle. Open with. Okay, right here. So let's say if we want to open with Notepad, you could do it here, okay? You can notice this one is better, Notepad++, added with Notepad++, okay? So that will give you what, you know, the file type. Now this file is, what happened? Oh, it's right here. So it's trying to do delete, trying to do what? Trying to do upgrade. So let's do, so you cannot do that. Let me just do, trying to do that. Let's try to just a Notepad. Okay, let's see. Open with Notepad again. Notepad, hopefully that. Yeah, that's fine. So basically, you're going to have something like a comma separated files, and it has, you know, first row is actually column names, and then then you have a list of cases, and the values are separated by commas, right? Okay, so anyway, if you have like Excel file saved into CSV, then you're going to, you can import that into R also. So this time, let's just say my data 2 equals to, I'll do is read.csv, okay? And then let's say CSV and then just file.choose again. And then you can say header equals to true, okay? And the strings as factors equals to false. So you can specify same kind of options again. And now let's say I will select just claims here. So now that my data 2 is opened. My data 2. So that's just, this file is pretty long, actually. lot of cases. So we probably want to use head and then my data 2. And by default, you only get a 4, 5, 4, 6 letters, six rows, unless you specify n. Okay, and then you can also use XML file. So to do XML file, let me show you one XML file here. You know what is XML, right? So where's my data here? Okay. So there's one called items.xml. Okay, let's drag that into downloads. And then there's one more thing. Let's say, suppose I want to I have a SAS file, right? Let's also download the SAS. Okay, put into downloads also. Okay, so let's try to open this two, and then we'll move on. Okay, do two more things here. So first, to do XML, let me show you what XML look like. So go to downloads, and then there is XML here. It's just trying to use open with Notepad. Okay, so this XML look like, okay, it has a like a prologue, and then it has like a one root element, and then it have a list of items. Okay, so let's try to import that into R. So to do that, we need to have a package called XML. So install packages, and then XML is all capital. Okay, and then library, and then XML. Okay, so after that, we will be able to just load the data. So that I think it's called items, right? I just use the object called items, and then so what we'll do, we'll call a function called to data XML to data frame. So XML to data frame. That function is not a read XML. Okay. So let's say file.choose again. XML to data frame. Okay. All right, and then let's say the items data is inside my download folder. Note. And then list the items here. Okay, so now if you type items, your data is in there, right? Okay, and so there's some other there's a SAS file. Okay, so let's try to do one more. So let's install packages. So to install any statistical package, to import any statistical package, we need to use a package called foreign. Foreign. FOREIGN, okay? Right, and then library, foreign. Okay. And then let's use let's try to read the SAS data file. Let's just say my data 3 equals to, I think it's called read.export. Export. Okay. And then the file name, let's just say file.choose again. Okay. Same thing. Okay. And this is the one I asked you to copy it over. It was export or XPD, right? Where is it? Where did I put it? It's not in here. Let me do it again. So it was in here. And then this XPD, access.xpd, I put into downloads. Okay, now let's do it again. Coming back to here, select a file, this one, okay, open. So now we have my data 3 opened. Okay, so that is how to import data. So I'm going to skip all the two other cases. For example, you can also scrap XML files, HTML files. So that's pretty common. You know, you have data coming from a web page. You know, how do you scrap that? So that I have slides to show you how to do that. But I'm going to move on because I really want to finish at least one application. All right, so this is for CSV file, and then for XML file, and then this data statistic package file, and this is web scraping. Web scraping. So basically, web page data tables can be. Let me just briefly show you, tell you what does it do. First of all, you specify where's the web page address. Okay, web page address, and then you're going to use read HTML. That will read the entire page into your in this case into the variable called a page. Okay, and inside HTML you're going to have many nodes, like HTML node, like a table node, like some kind of HTML each node. All the nodes will be in here, but we want to just get a particular node called a table node. So that will give you a list of tables by using this HTML nodes function to extract the list of tables. And then you can just specify one table you want. So suppose I want to get only table 5, and then this table 5 will be used to convert into data frame. The result is really not a data frame. It's called a table, just similar to data frame. It's more complex like data frame. But then after you have that table, then you convert into data frame. So now you have a data frame. Just a few more steps to scrape a web page data. Okay, it's pretty useful. And also show you how to load data from an Oracle database. So I'm going to skip that too. Okay, and now let's do one application. Let's do regression. Regression is the simplest one, right? Okay, so let's say suppose let's just look at the data trees here. Okay, that's a pretty simple data set. Let's say whether we have any relationships, anything that we want to do linear regression. So first of all, let's explore data, right? So let's say pairs, okay, pairs of trees. So then you'll see something like this. You probably will say that volume somehow is related to height and the girth in some kind of linear relationships, right? So that gives you an idea that is possible that you can create a linear regression against to predict, for example, use girth and height to predict the volume, something like that, right? And to do that, you still need to make sure that when you do linear regression, the predictors should not be linearly related, right? That's called collinearity. So that should be avoided. So let's try to do that. Okay, trying to see whether there's any collinearity, right? So I'm going to do is I am going to use correlation function for the trees. So to find out what are the possible correlations. So let's say COR here. So at this point, I found the correlation between each pair of numbers. So if you found out the two predictors have a kind of correlation between over like a 75%, then it's probably bad choice for the predictors, right? So if that's the case, I'm going to use a function find the correlation, find the big correlations, so that which one has big correlations, and then we'll see which one has big. So to do that, I need to have a package called carried package, and then say carried. And then install on the library carried. Okay, so this package has two functions that we need. The one function is find the correlation that is big with certain cutting point. Another one is say we want to find any predictors or have some kind of a linear relationship, so called collinearity, right? Which is bad for linear regression. So I will just use a function called find correlation, find correlation, okay? So from this, so this one has a very small matrix, is this, small correlation, but sometimes, you have a lot of columns, then you're gonna have a large correlation matrix. So you probably want to use this function to find out which one is big. So I would just say cut off equals to 0.75. Suppose, I'm only interested in finding that, finding those correlations, which is bigger than 75%. Okay, so then you will find out that, the variable 3 has a huge correlation. So which is a volume, right? Which is okay because that's the consequence. But if you found that if girth and height have some kind of high correlation, then that's problematic. It probably means that you have some kind of problem. Okay, so I think we have a package. There's a data set called cars, I think. Is it? Not here. Okay, let's say data cars. Let's load that and the cars again. Yeah, that's one. So if you have to load the data, say data cars. Let's use the car. Okay, so then to cars again. So that one will give you a lot of variables here. Okay. So again, correlation function. Find the correlation function is inside the carried package. Do you have carried installed? Part of, yeah. Just say find. Okay, let's say let's do one more correlation here. Let's say correlation 2 equals to let me see. Let's look at the structure of cars again. Cars. I think the first column is the price, second column mileage, and yeah, we can do correlation here. Let's say cars, let's say CRO2 equals to correlation of cars. Okay, so then this time we are going to have a huge matrix, right? So let's say I want to, in this correlation matrix, I want to find the big ones, okay? So let's do find correlation of COR2, and then we'll do cut off equals to let's say 0.8, okay? So find things high correlation bigger than 0.8. So we have found that variable 4 has some kind of correlation, which is, if you narrow down to that, narrow down to variable 4 has some kind of correlation. So variable 4 is 1, 2, 3, 4. This one, the doors. This doors has some kind of correlation with some other numbers. So if you look at that rows, you should be able to find that. Okay. Now, we can also just use another function called find the linear combinations. So that is actually probably more interesting because you can find directly which ones are related linearly. Okay. So if I do find linear combos, okay, and then put say trees here. Okay, let's do trees first. So you will find out that there's nothing here. There's nothing which are linearly correlated. But if I use the same function, find the linear combos to cars, you will find out that there are 2 linear combinations. So there's item 15 is linearly related to these variables. And then variable 18 is linearly related to those variables. So before you do linear regression, you should get rid of those 15 and 18. So that gives you some kind of a pre-processing for applying linear regressions. Okay, but now let's try and say in our case we don't have that trace, we do not have that problem, so we can just directly use linear regression. Okay, so let's create a linear regression model equals to LM. Okay. So M is the model I want to estimate, and then we want to use a volume to regress against girth plus height. Okay, girth. So one predictor is girth, another predictor is height, and then data is trees, using data trees. So if you have like a training data set, if you separate into training and the testing, then you just, you can use training data set instead of just entire data set. Okay, so now let's get that result. And now this is MN, that's the model we just get. And now if I do summary of MN, okay, who can tell me whether this result is good or bad? So first of all, you get a list of residual summary. So residuals can actually obtained by MN and then $, and then residuals. Okay, so you know the residuals just like a difference from actual observation from the predicted values, right? So the bigger residuals means bad result, right? So this gives you a list of residuals for all the observations, but the first one give you the summary of that, okay? And then the second part would be just coefficients. So basically, if you look at this one, this so-called probability p value indicating that whether that particular value is significant. So it's doing some kind of hypothesis testing here. So it's testing whether coefficient for girls is 0 or not, and null hypothesis is equal to 0. So in this case, you reject because the high value, what is the p value is pretty p value is pretty small. So basically, it just indicate that this interceptor, girls, and height, they all have significant coefficient, which is significant different from 0, right? So those numbers are pretty good. And then you look at this so-called R squared. R squared is pretty good too, right? So that means your result can explain 94.8% of the variance of the observations, right? So this is a bigger the better. And then there's also F test. F test just test this model against empty model. Empty model does not have any predictors. So anyway, if you look at these numbers, they all look pretty good, right? However, let's just check the residuals again to see whether this is indeed a good model. Okay. So what I'm going to do is I'm going to plot 4 different residual plots. So I'm going to just say create a partition first. Partition. Let's say MF row equals to C 2 by 2. Okay. And then I will plot, and then N. Okay. There we go. So now we have these 4 plots, and now you can tell that the first one, the first one is what? So is what's called the residual against the fitted value, and this line should be straight. Should be around this, like this dashed line here. Should be average. Should just sometimes up, sometimes down, but should be hugging around this one. But this is not. This is actually what does it mean? It just means that this this is probably not a linear relation. Okay. So the relationship we're trying to say the volume equals to A times height and then plus B times curve. Probably that relationship is incorrect. So this indicates some kind of nonlinear relationship here. And this part is fine. This just checks if whether residuals are normally distributed. This is fine. And this part also should be straight line, should be horizontally straight line. So what does that do? What does that mean is this, the residual should have a standard deviation, constant variance across different values in different range of values. But this is not correct. And this one tells you whether there's any outliers. And there's something called Koch lines. Okay, so if you have any observations out of these Koch lines, that means you have outliers here, right? So even though we have very good numbers, but the result is, this graph showing that we do not have, the model was not correct. The model was not correct. So why is not correct? You understand that because volume is not really. So what is tree volume? Tree volume is really just like what? Just like should be predicted by height multiplied by the area, right? It's not really. It's not scientifically they are not in a linear relationship, all right? So if you do statistics, you probably publish the result, say this is a good result, but actually it's just garbage, right? Okay, so let's say how can we improve this result? So I have trees here, right? So what am I going to do is I'm going to create let's do facial transformation. Okay, I create a new facial, new variable. Okay, for these trees, and the new facial is It's a new predictor, so trees, okay? So the new predictor, I can just name it as what? As, let's say, as predictor, okay? Predictor equals 2. So the new predictor is going to be what? Using the tree's height, trees $sign height, and multiplied by the area of the tree. Area of the tree is a pi r square, right? So it's a pi times r square. So how do I get r? R is, the girth, the circumference is 2 pi r, right? So if I use girth, that's girth, which is trees girth divided by 2 pi, divided by 2 times pi. That should give us the radius. And then from the radius I squared, that should be better predictor. Okay, so now we created a new feature called a predictor from the existing ones. Okay, by using the tree's height multiplied by the tree's area, and then we, let's say the trees again. So we have a new variable inside called a predictor. Okay, and now we can use that to create a new model M2 equals to MM, and now let's say just volume versus predictor. Okay, and the data is same as trees. Something wrong? It's called a predictor or something wrong? Predictor. Okay, so I misspelled. So this time I have to do predictor. So now let's say summary of M2. Summary of M2. So the second model. So second model, if you look at numbers, slightly better, the R squared is slightly better. And then if you look at this this coefficient, then this p-value is so big. So that means the intercept should not be there. The intercept should not be there, it's not significant from 0. So let's create M3 equals to Lm, and then just say volume regression against predictor. Okay, but then I need to take off the coefficient, so that I predict the intercept. So let's remove the intercept, which is -1. Okay, and then data equals to trees. Okay, so now we do summary of M3. Now this time you see that this is a very good result. Okay, R square is 99.9%. So that means, the linear regression I get can explain 99.5% of the variance of the volume, actual volume. Okay, so that result is pretty good, and also this is significant. Now let's plot of M3, and now let's see whether we have a better result. What happened here? This result. Where's the plot? Window, graphics here. Okay, this is the plot. Now you see that this is pretty much what? Linear, hugging around horizontal line. So that means the relationship with size is pretty much right. Yeah, pretty much right. So that facial transformation was good. And now this one is, the residual value is still pretty much straight line. That is pretty good. But then there's no outliers, so that's good too. But then what about this one? This one is still not that good. This one's still not that good. So that means in this data set, the constant variance, probably the assumption probably is not much observed. Okay, so that is still not that good. So I guess it's probably because some trees are big, some trees are small. So you may need to continue to fine tune that data set. So anyway, that is one first application, and that's good. We can do one more application, then we are done. Okay. So let me do so linear regression. Okay, I'm going to skip all that. Okay, so now let's do one application that may not be that basic. Is called the Bayesian learning. Okay, have you ever thought about Bayesian learning? Bayesian network is actually probably the most general form of a machine learning model. Is a generalization of any model you can think of, like linear regression, logistic regression, anything else, no, deep learning. So it's generalization of all that. Okay. So what is a Bayesian network? Is basically using so-called nodes. Use network. Use nodes to represent variables. And attached to each node, you can have some kind of probability table that will be representing something called observations. And then use arrows. Arrows will be indicating, which variable impact which other variable, or you can think of, a lot of people think of that as like a causal relationships, but it's really not a causal relationship. It's more like a so-called dependence. So whether X and Y have some kind of dependence or not. So it's a correct way to interpret that is a conditional dependence. Okay, so use arrow to represent that, and then use conditional probability to representing the magnitude of that impacts. Okay, so let me give you two special cases of linear models. So if you some of you do some kind of sentiment analysis, or maybe like similar technique, like detecting, say, whether message is a fraud or not, something like that. So basically, in those cases, you are going to use the presence of words. So for example, say, if you have a word sad and boring, those kind of words, and then, you have negative sentiment for the message of some for movie or something or product. Then if you have some kind of positive words, then you typically think that, the message is positive, right? So you do sentiment analysis. So this is so-called naive Bayesian. The naive Bayesian classifier is a special case of Bayesian network. So in this case, if there's a strong assumption, that means the strong assumption that is all those nodes outside are conditionally independent given the sentiment. So if you're assuming that this message is positive, then whether you have positive, what kind of positive words you have are not related, not independent in other words. Given that that message or the movie is positive, then those positive words will be independent, or negative words will be also independent, something like that. So that's strong assumption for naive Bayesian, but it's a special case of Bayesian network. Okay, so this is I'll give you a second example. Second example is called a hidden Markov model. So let me just give you one application. Suppose you receive some kind of cryptic message. Okay, let's say the message consists of this x1, x2, those as special characters, cryptic. So you cannot know what is the actual meaning. But actually, what's behind us actual letters, maybe like a Z1, Z2, Z3, those type of things. Okay, so you're trying to use this model to detect, to decrypt what was actual message, like Z1, Z2, Z3. Okay, from what is given to you. So what is you detected? What is you received? Which is the encrypted message, right? But you don't have a key, right? So you can use hidden Markov model to do that, right? So this is actually Bayesian network too, special kind of Bayesian network. So each node is just a variable, and then those arrows pointing just saying what are the conditional probabilities. All right. So that is of course this pretty advanced stuff, but what we'd like to do is just show you how Bayesian learning is actually pretty simple if you want to use our package. Okay. So let's say suppose I give you a data set. Okay. And then you're trying to explore the data, and then there are all kinds of possible relationships. You want to do linear regression, you can do that. You can just say, this relate to that, this relate to that. But sometimes one variable may be related to many other variables in some kind of ways, right? So let's just say, suppose you are running out of ideas, say which variables are really related, and then we probably want to try Bayesian learning. Okay, so what does that do is the Bayesian learning just using some kind of some kind of search to systematically search all possible different combinations of how these variables are related. Okay, so I'm going to show you one example, which is pretty big data set and a lot of variables, and it will be impossible if you do some kind of alternate traditional approach to say how those variables are related. So let's do Bayesian learning. Okay, so Bayesian learning has two parts. One part is called structural learning. That's basically learning the structure of networks. So which variables are related by, by arrows, which are not, okay? And the second part is after you have the structure, then you learn, what are the probabilities should be estimated for that network. Okay, so those are so-called the probability learning. So basically, you feed data to the network. Okay, so I'm going to show you. Let me just go back to R, and then I ask you to load one package called bnlearn, right? So let's do it again. Install packages, and then bnlearn. Okay. And then let's library bnlearn. Okay, and besides this package, I also need another package which will help us to visualize the network. Okay, so that is biocode manager. Install packages. It's called BIOC manager. It's pretty fast. And now I'm going to use the biocode manager to install the graphical package called R graphics. Okay, let's say we'll do BIOC manager colon, and then type install, and then inside here, going to say R graphics. So update all, let's see, we do not need to update all. So we can say maybe just no. Okay, so now this is our graphics is loaded. So let's load that, let's install, let's load that package also. R graph this. Graph this library R graph this. Is visualized. Something wrong? There's no package called graphics, so I installed that. Did I misspell something? Let me see. Download the version. Okay, let's see. I did install or install pass node, download binary. So anyway, that graph has some kind of installation issue, so I do not have time to fix that. But I will just use simple plot to do it. Okay. So let's say we have a data set. Let's say data set is called alarm. Okay. And then if you look at the alarm here, it's a huge data set. Okay, it has like a 27 some rows here and a lot of variables. Let's say names of alarm. So like 30, I think like 37 variables, right? 37 variables. And this is data set for some kind of like a monitoring health, some kind of, so under certain conditions, certain symptoms can appear, can happen. So let's just say if I have the data set, I'm trying to learn the network, okay? So what I would do is say net equals to, I'm going to use one of our algorithm called hill climbing alarm. Okay, very simple. Okay, take no time. Okay, and then let's say what the structure look like. We just plot it. We just use another plot. This is the place I want to use graphic viz to plot, but unfortunately, the package installation has some kind of trouble. So we will just use a regular plot, and then you're going to get a plot. So if you look at your windows here, graph this, it's pretty nasty here. But I'm going to show you that the graph. If you use graphical viz to display it, is actually better. So this is what it looks like if I do it using like a graphic viz. Okay, so all the 237 variables are listed here, just telling you how these things are related. So that basically gives you some kind of idea, which variables and the variables are really related, right? So instead of trying to try every pair, every possible combinations, but this one give you better starting point, right? So after you have that, and then we can just use this to put in the data and then try to estimate probabilities, including conditional probabilities, all that. So then you get something like this, a bunch of probabilities, okay? So the function to do that is also simple, just say bn fit. So let's just say, fit equals to bn, Bayesian network fit. And then let's say the network I want to estimate is net, I just estimated, and then the data set is alarm, okay? So now if you look at a fit, then it has all the probabilities you're looking for. And so based on these probabilities, conditional probabilities, you probably can just make some kind of judgment, say, this path is probably strong, this path is probably weak, something like that, right? So after you have that, and then if you say you want to fine tune that to create a better Bayesian network, is one possible path, or maybe you want to use one of the traditional approach, like like a linear regression, logistic regression, or some other approach to trying to see whether variables are related, right? So that will give you some kind of a way to just to explore the possible relationship among variables. I think that's it. That's for today's the tutorial. I finished 60 slides, and then there are like 20 more slides about some special topics. For example, if you have like a NoSQL database, have data set from here, there, and then trying to pull all together, how to do that, right? So there's a Bayesian data set, and there's some other special topics, how to handle mixing values. Okay, so those are not very common situations, but I will just at least put those in the slides just in case you are interested. You can just continue to look for those. Okay. Otherwise, that's it. That's all for today. Does anybody have last minute questions?
Yes.
Yeah.
So you're recording this and,
Oh, it's recorded. Yeah.
and it'll be stored somewhere. Is there any way I could access this again?
Good question. So I will, you know what? I will upload to YouTube, and then I will put a link into the same file that you downloaded data set and the
blog?
presentation. Yeah, the blog. Yeah. How's that? Okay.
Excellent.
So it will be in YouTube, and then you have a link, and then you can just go to YouTube to look at it. Okay. All right. Any other questions? Thank you all for your presentation.
Another question.
Yeah.
How do I save what all we put in our R console?
Oh, how do you save everything you have? So you can just type save explicitly into some kind of like R data file, or if you exit, ask you to say you want to save it, and then in that case, you will save a file called rdata. That's default. Okay. Oh.
So Rails outstanding things.